Right. Good morning, Year 7. So today we're going to be starting a new topic about space, and the first thing we need to understand is our own little corner of space. So we're going to be looking at the solar system, and of course the centre of the solar system is the sun. So we're going to look at light from the sun and how it affects the Earth. So today all of you should know how we get energy from the sun, explain the importance of the sun to the Earth and how we get day and night, and a few of you explain in detail how the Earth moves in relation to the Sun. Firstly, I'd like you to explain these three words. I'd like you to write these down in your book and try and come up with definitions for their meaning. Okay, so you've got luminous, reflect, and spins. Okay, luminous, reflect, and spins. Let me just put those all together so that you can. Right, so luminous, reflect, and spin. So pause the video and write these words down and look up a definition for what they mean, particularly if you can in relation to the Earth. Okay, so welcome back. So luminous is something that gives off light. Okay, reflect is when light bounces off an object. And spins, at least in relation to Earth, means it is rotating or moving around. Okay, so let's have a closer look. This is the sun, and it's not drawn relative to the Earth. Okay, so let's think about what we need the sun for. Okay, well, the sun basically gives the Earth heat and light. Okay, and as we can see, the sun's heat and light hit the Earth, but a lot of it is passed back into space. So here, some sunlight is bounced back into space. It hits the Earth and off it goes. It reflects. Extra heat is kept in by air, by greenhouse gases produced from human activity. Okay, so this is sort of showing how the sun warms up. We have greenhouse gases in our atmosphere, and what happens is we need these. Now, you've probably heard of greenhouse gases as being bad. The reason is because we're upsetting the balance. We're, as humans, probably producing too many. Okay, but what we need greenhouse gases to keep our atmosphere warm. Otherwise, pretty much all the sun's energy would simply bounce back into space. So, in its simplest terms, the sun is a star and gives out two things: heat and light. Okay, now that sentence is something you need. So you can just pause the video one more time and just write that. The sun is a star and gives out heat and light. Okay, welcome back. Now, the sun is 150 kilometers away from Earth, and the sun's rays travel through space until they reach the Earth, and it is luminous. Okay, that means the sun gives off its own light. That's how we see it. And I'm just going to show you a cool little way of using maths to work out how long it takes for the sun's light to reach us. Okay, now we can actually do this. Because what we need to know is we need to know the distance, and if we divide that by the speed, we can work out the time. So if we know how far away the sun is, which we do, and if we know the speed that light can travel, which we do, we can work out how long it will take to get to the Earth. So the distance is 150 million kilometers. However, we always have to put that into meters, and since 1 kilometer is 1,000 meters, we need another 3 zeros. So here's how many meters the sun is away from the Earth. So a meter is about an arm's length. Okay, or like your arm span. Okay, so 150 billion arm spans away. All right. Now the speed of light, we also know, 300 million meters a second. Okay, that's how fast light goes, and it's the fastest thing ever. If we do distance divided by speed, we can work out the time. So I'm just going to quickly pull up a calculator and show you what I mean. So, very quickly, I do 150. Right. So 150 million, there it is. Now I divide that by the speed, which I just said was 300 million. And that gives us 500. Now, so the time is 500 seconds. So it takes 500 seconds from light to travel from the sun over to the Earth. And if we just divide that by 60, because there are 60 seconds in a minute, so 8.3 minutes. Okay, so if the sun were to suddenly just switch off right now, you won't find out about it for another 8 minutes, because that's how long it would take the last light to get to Earth. Okay, interesting little thing there. So the sun's light helps keep the temperature on Earth suitable for light. It's roughly a sphere, and it's much, much bigger than the Earth. And just to give you a little bit of an idea, here's the sun. These are all the planets in our solar system. Remember, Jupiter's the biggest. Look at how tiny Earth is compared to the sun. The sun is by far the biggest thing in our solar system. Okay, and there's Earth, that's us, tiny little dot just there. Okay, so that's how big we are. The whole of the Earth is compared to the sun. But of course, it's the planet that we live on, so it's important to us. Right, now I'm going to need you to draw a diagram like this in your book, please. Okay, so pause the video quickly and can everyone draw this diagram in their book? Okay, welcome back. Now, what we know is about certain things is this. Okay, the sun is at the center of the solar system and the Earth goes round the sun. So essentially what happens is the Earth will follow a route around the sun. Oops. Like this. Okay, so go all the way around the sun, and I haven't drawn that very well. Right, sorry about that. So as you can see, the Earth goes round the sun. Okay, so the first thing you need to do is write that down. So somewhere on next to this diagram, maybe underneath, the Earth goes around the sun. Okay, and you've got to think, how long does that take? Well, that takes 365, actually, and a quarter days. That's why we have leap years. Okay, so 365 and a quarter days for the Earth to do a lap of the sun. Okay, and also something else goes around. The moon also orbits, it goes round the Earth. So let's write that in. Okay, welcome back. So these are the two things you should have so far. The moon, sorry, the Earth goes around the sun, and that takes 365 and a quarter days. And the moon goes around the Earth, and that takes 28 days. Okay, there it is, 28 days. Now, there is something else. How do we get light from the sun? So if you're here on the Earth, which is where we are right now, let's think about how we get our light from the sun. Right, it's very simple. Light travels in straight lines and hits the Earth. Okay, right. So on this side of the Earth, it is daytime. But let's think logically about what else we know. People living on this side of the Earth, for them, it's night. Okay, so what we're going to do is just going to shade that side in as slightly darker. Okay, there we go. So what we can now see is we have nighttime. All right. One other really interesting thing, how do we see the moon, particularly at night? Okay, the reason we see the moon is not because it's luminous, because it gives reflected light. So what happens is the sun's light hits the surface of the moon and then bounces back down to Earth. So that is how we see the moon. So the moon doesn't have its own light, it's non-luminous, it reflects light. Okay? And sometimes you'll notice you can see the moon during the day. The reason for that is this. Okay, think about how light travels. Sometimes it can just travel like that. So you can see the moon mostly at night, but sometimes during the day. Okay, so how do we get day and night? What do you think happens? Right, so I'm going to ask you to go into the video link in assignments and watch the video now. But the first thing you need to do is pause the video and make sure you've got a diagram that looks like this. And you have to have the key information. So, key information, a couple of sentences for each. The Earth goes around the sun, and that takes 365.25 days. The moon goes around the Earth, and that takes 28 days. The sun's light hits the surface of the Earth and gives us day. You can think about when we get night. Okay, and how are we able to see the moon? That one's going to definitely need a couple of sentences. Okay, how are we able to see the moon? So pause the video now. Make sure this diagram is complete with sentences, explaining it in your own words, and then watch the video link. Okay, everyone. Now, in assignments, there is a PowerPoint, and which gives you some information, and then the task is on the sheet. So I'm just going to quickly talk you through your task for the remainder of the lesson. Okay, so you're going to study the work of two astronauts. Whoops. Apologies. Right, Thelma is an astronaut and works at the Kennedy Space Center in Florida. That's about there. And she gets to work at 9 AM every morning. However, Vladimir works at the Russian Cosmonaut Center in Moscow. When Thelma goes to work at 9 AM in Florida, it's 5 PM in Moscow, and Vladimir is getting ready to go home. So he's over here. Right, so let's have a think. What causes this time difference? So 9 AM here, 5 PM over here. So, using some of this information, make a poster to explain to Vladimir and Thelma why Thelma gets to work in Florida at 9, and in Moscow it's 5 PM, and Vladimir is getting ready to go home. So some key words: axis, 24 hours, night, day, earth, shadow, and sun. So I'll leave this PowerPoint up for you. Okay, so make sure you can answer all the questions on the sheet, then upload your work for assignments. If you do it in your book, you can just snap a picture on your phone and upload it that way. And then as a challenge, in places like Iceland, so far north within the Arctic Circle, right now it's daytime all the time. But at the South Pole, it's nighttime all the time. Can you work out why? Okay, and if you can do a little extra explanation on that. So, just to quickly show you one other thing. This is the sheet which is an assignment. So, it asks, how does Vladimir wake up in the morning while Selma is going to bed at night? You're going to explain why we have day and night. So, this was the experiment I was going to do. I was going to use a globe. And if you've got a globe at home, you can do this yourself. Put a source of light next to the globe and spin your globe. See what happens. And then use the ideas from the PowerPoint to produce a poster to explain why he wakes up while Selma is going to bed. So, a few things you need to include. In the solar system, where does light come from? You need to explain that in your poster. What word describes something that gives off light? One side of the Earth is in shadow. Why is light unable to travel through the Earth? When part of the Earth is in shadow, is it day or night? What do we call the imaginary line through the north south? You would have got that from the video. How long does it take for the Earth to rotate once on its axis? And where does the sun appear to rise and set? And then, I don't know why this is 4, 5, 6, and 7. When part of the Earth is in shadow, is it day or night there? What do we call the imaginary line? I think it's already got that. Yeah, okay, so that's just a repeat, so ignore that last bit. Right, so it's basically just these questions here. Now, I want to see some diagrams, okay? So make sure you include diagrams to explain how you get day and night, all right? I'm actually going to put a couple of videos into the assignments, so hopefully you'll be able to see them all. And as always, I will be online to help you out. Okay, everybody, good luck.